This is Mr. Rupp as Golf Ball Head, and today we're talking about Algebra 11-6, rational expressions with like denominators. Okay, not too terribly difficult, so don't freak out, and me and Mr. Golf Ball Head will help guide you through. Okay, let's start. Adding rational expressions with like denominators is exactly the same as adding fractions with like denominators, okay? If you had 3 over 7 plus 5 over 7, then you would take 3 plus 5 and write that over the common denominator, 7. And this would become 8 over 7. We're going to leave it as an improper fraction for now and just not worry about it, okay? This methodology right here is exactly what you do for rational expressions with like denominators, okay? So let's try one. Example 1 here on page 608. Okay, it says 3n over 12 plus 7n over 12. So you have 3n over 12 plus 7n over 12. So that becomes, I'm going to write this out in excruciating detail, 3n plus 7n over 12. This becomes 10n over 12, and you always write your answers in simplified form, okay? Now, ignore the fact that I left that 8 over 7 up there as an improper fraction. It's still in simplified form. Alright, what you can do is you can take out a 2 from both of these. So 10n divided by 2 is 5n, and 12 divided by 2 is 6. Okay? So 5n over 6 is your answer. Let's do one now where you have a binomial in the denominator. As long as the binomials are exactly the same, it's the same process. Okay? So here we have 2x over x plus 1, and you're adding it to 2 over x plus 1. Okay? So you combine the numerators and write it over the common denominator. Okay, so you have 2x plus 2, and that's over x plus 1. Alright, to simplify this, you factor out a 2 from the numerator, and you're left with x plus 1 over x plus 1. And boy, don't we like this. We can cancel. We whip out the pen of a different color, chop those off, and we're left with 2. That's your answer. Okay, moving on. Well, alright then. Here we have a perimeter. We have a parallelogram. Okay, PQRS. And remember that just like a rectangle, the opposite sides of a quadrilateral, or the opposite sides of a parallelogram in this case, have the same length. Okay? So that means then that for the perimeter, the P, we're looking at 2 times the length plus 2 times the width, just as if it's a regular rectangle. Okay, now does it matter which one is the L and which one's the W? No, it does not. So let's just pick it. Alright, that says that we have 2 times 4a plus, oh Lord, 4a plus 5b all over 3a plus 7b plus 2 times, and this is the other side length now, 2a plus 3b all over 3a plus 7b. Okay? Right. We have a common denominator. So what we're going to do is we're going to write the numerators now over this common denominator. So the numerator for the first one is 2 times 4a plus 5b plus the numerator of the second one, which is 2 times 2a plus 3b, and all of that is over the common denominator, 3a plus 7b. Okay, so coming back over here, we're going to multiply the numerator out discretely. So looking back at that expression over on the right hand side there, we have 2 times 4a, which is 8a, plus 2 times 5b, which is 10b, plus 2 times 2a, which is 4a, plus 2 times 3b, which is 6b, and that's all over 3a plus 7b. So now we're going to combine like terms, okay? So the two like terms that we're going to combine first, 8a plus 4a gives us 12a, plus 10b plus 6b, which is 16b, all over 3a plus 7b. All right, what can we do with the top? What can we factor out to simplify this? Well, the greatest common factor between 12 and 16 is 4. So let's factor out 4. Okay, and that leaves us 3a plus 4b all over. Okay, so 4 times the quantity 3a plus 4b over 3a plus 7b. And that is our final answer. Okay. All right. Let's do one now where we're talking about subtracting rational expressions. Remember that when you subtract an expression, you are also doing something called adding its inverse. Okay? And that's called an additive inverse. So in this case, we have 3x plus 4 over x minus 2 minus this quantity, x minus 1 over x minus 2. All right. So what this becomes then is this. Remember, the x minus 2 and the x minus 2 are common. So we write the numerator then, 3x plus 4 minus x minus 1 all over x minus 2. We need to add the inverse of x minus 1 here. So we have 3x plus 4 plus, we want the inverse of x minus 1. So the inverse is that negative sign right there, x minus 1. Okay? And that's all over x minus 2. So this here is the additive inverse. Okay? All right. So what this comes out to be then is 3x plus 4 minus x plus 1 all over x minus 2. So coming back over here then, we combine like terms, so 3x minus x is 2x, okay, and 4 plus 1 is 5, and that's all over x minus 2, okay? This is your simplified answer. Okay, pause the video, try this one on your own, and see what you come up with. All right, we're back. So we have 3m minus 5 over m plus 4 minus 4m plus 2 over m plus 4. So we're rewriting the numerator now over the common denominator. 3m minus 5 minus the quantity 4m plus 2 all over m plus 4. So what we want to do is we want to add the inverse of this guy right here. So coming back over here, we have 3m minus 5 plus the quantity, the additive inverse, which is what this negative sign is, 4m plus 2. and that's all over m plus 4. Okay, so simplifying this, 3m minus 5, we have minus 4m, and then the negative 2 carries through, distribute the negative across here, so it's negative 4m, which is what we've got, and then negative 2. So minus 2, and that's all over m plus 4. Okay. So now combining like terms, 3m minus 4m gives you a negative m, and negative 5 minus 2 gives you negative 7, and that's all over m plus 4. Okay, and that's your answer. Just like that. Moving on now. So, what happens if you have inverse denominators? All right. This is why we talked about additive inverses just previously, because you're going to need to employ that here in order to solve these. So you have 2m over m minus 9 plus 4m over 9 minus m. You need common denominators to add rational expressions. So we need to rewrite 9 minus m as its additive inverse. Okay, so here's how we do that. 2m over m minus 9, okay, plus 4m over negative m minus 9. Okay, so here's the m minus 9 and the m minus 9. So we rewrite this now as 2m over m minus 9, and now this negative sign comes up to here and it becomes minus 4m over m minus 9. All right, now we have common denominators, and we write the top, the numerators, all over that. 2m minus 4m over m minus 9. So we have negative 2m over m minus 9. Okay, and that's the answer. All right. Okay. So pause the video and try this one for yourself. Okay, we're back. So we have 3s over 11 minus s. These are all s's, not 5s. Oh, I hate it when they do this. Plus negative 5s over s minus 11. All right, so we need to change this s minus 11 to 11 minus s. In other words, we need to change it to an inverse, okay? So here's how we do that. We have 3s over 11 minus s, okay, plus negative 5s over negative 11 minus s, okay? So now this becomes 3s over 11 minus s. If you have a negative over a negative, what's that give you? It gives you a positive. So we have plus 5s over 11 minus s. Okay, so we have 3s plus 5s over 11 minus s, and that gives us 8s over 11 minus s. Okay, and that's our answer. Okay, thank you for watching this to the end. Remember what I said about canceling factors above in the numerator and the denominator. You cannot just find ones that look the same and chop them out. They have to be as products, all right? They have to be factors, not just appearing in the numerator and denominator. That's really, really bad math. Do not do that. Thank you for watching, and I will see you guys next time. Okay? Bye!
Get down to the B-side.